Good morning, folks, and thanks for joining. As Yasmin stated, we're going to look at that elusive east-west traffic. So I had for years the challenge of troubleshooting physical networks, taps, spans, etc., gaining access to packets, as well as using other tools like SNMP, NetFlow, etc., but it never addressed that east-west traffic, which is now in our virtualization space. Private cloud as well public cloud. And that's always been the problem. How do I address that traffic? Because that's usually where all my back-end traffic, my middleware traffic, where all the delays for applications usually take place when there's an application issue. So visibility in that layer is crucial, and that's one of the sweet spots of what we're going to show you today with respect to the Siegen product offering. So east-west traffic, address both infrastructure and application requirements, non-intrusive visibility to data center integration, full application change to insight. Once again, let's face it, it's the web tier that the customers are seeing, the end users, and what's happening behind the scenes is in this east-west traffic. That being, once again, databases, middleware applications, etc. We need that visibility. And then fast time to value, and then low total cost of ownership, generally in the data center. So from a Siegen perspective, we offer a number of products. What we're going to focus on this short webinar today is PBX Performance Vision, which gives us layer 2 through layer 7 network performance management and application performance management visibility of all the packets. And we'll address that in a big way here. But other products that are offered by Siegen that lend itself to an overall architecture are Flow Broker, FBX, which gives us visibility to some of those challenging edge devices and remote location challenges as far as seeing the packets and deep packet inspection. And then VCX for synthetic transactions to baseline our underlying infrastructure down to microseconds, so we understand where microbursts are occurring, etc., so we can troubleshoot those carrier issues quickly without having to do a lot of manual troubleshooting. And that all rolls up to our new product, very proud of it, Data Hub IQ, which I'm sure we'll have other seminars on. That is a performance management dashboard that's very cutting edge. You'll want to see that. So from a packet to actionable performance insight, as Yasmin stated, I'm all about the packets, because let's face it, packets give us nanosecond, microsecond granularity in the data center where it's generally low latency or across multiple data centers or across the public cloud, the private cloud, and the hybrid environment. Packets don't lie. We see all the information, all the data is there. No more finger pointing, no more guessing. All the analytical data resides in the packets. So from a network perspective, we gain access to the traffic through span ports, tap ports, Flow Broker, and other resources, as well in that east-west traffic that we're going to talk about, how we gain access to those packets. And then with Performance Vision, as soon as that information, that being the packets, hits our interfaces, our capture interfaces, we're analyzing it. We're doing the work for you. We're eliminating that step of post-packet analysis that we all grew up with, where I pull out a trace, fire up Wireshark or whatever tool, packet analysis tool I so desire to use, and have to do the analysis. It's doing it for you, but it also gives you the ability to have a packet trace too. So from a network usage and performance perspective, Performance Vision gives you that. Transport layer TCP, we do an awesome job. There are some key metrics that no one in the industry provides. And then all the way up the application stack within the packets, we're giving you application layer details so you can solve and point to where application slownesses are occurring to help those app teams understand where problems reside, where they can look and find the problem that's slowing up the end user response time, overall application transactions. So from a troubleshooting perspective, proactive monitoring perspective, collaborative optimization perspective, and change control perspective, Performance Vision brings you the insight you need to solve those problems and have the full life cycle coverage. So real-time, full stack visibility. Once again, as you see in this slide, PBX capture interface, as soon as that data hits the wire, that being packets, we're analyzing it. Once again, eliminating that post-packet analysis requirement. Real-time analysis, 100%, no sampling. We're looking at every TCP transaction, every TCP session, analyzing it, and then moving up the OSI model within the packets through layer 4, through layer 7, to give you actionable insight into various applications and network protocols. And then we're bringing it into the data store, the PBX data store, which is where our intelligence is, where our GUI resides, and that's a central place where you'll gain access to that rich information that we're getting out of the packets very quickly. So it's both a network performance management and network application performance management solution, and we'll talk more about that. So here's where we broach, from a true APM solution where you're actually deploying agents on servers and in application environments and looking at application code running and processes and services. We take it to the level of at the edge there, right at the network, where once again we're able to show you at the application layer what's happening across the network. In a lot of environments in today's modern, Docker and Hadoop environments, the network is a huge part of the application, more so now than ever. So visibility at the network layer all the way up the stack is crucial. It augments what you do at times with the APM solutions, or in a lot of cases it will replace it because it streamlines the operation and makes it more cost effective. So today we're going to take a look at VMware from that EastWest Traffic perspective. We're going to focus in on ESXi, and we're going to take a deep dive into packet layer analysis. So I'm just going to stop here for a second and verify that my environment's up. So from a switch and router perspective, we're above that. We're at the virtualization layer. We're at the hypervisor, looking at the virtual distributed switch. And we're going to dive into this demo shortly. I just want to make sure my environment was up. So from a VMware perspective, ESXi 6.7 current release, we're going to give you insight into the virtual distributed switch, the package traversing that on an individual hypervisor or across multiple hypervisors. So as you can see here, the PBX capture appliance has an administrative port where we assign an IP to it just like any host in the environment, so we can talk to that device. And that's generally on your network management plane or your management plane, your VLAN. And then we have the actual application of a virtual switch where actually the transactions are taking place between server to server, load balancers, firewalls, etc. We're seeing that traffic go from those host environments, clustered host environments, to those environments. So we're seeing all that, once again, east-west traffic traversing your virtual space. And the way we do that is, once again, mirroring two interfaces on the PBX appliance. So we could have up to 8 capture interfaces in addition to the one administrative interface. So we can scale out very nicely for each hypervisor and across multiple hypervisors. And it's a lightweight appliance. So the PBX appliance, virtual appliance, is lightweight, from a capture perspective. So it's not putting a huge burden on your environment to have this deployed. So we could do that across virtual standard switches, utilizing port groups, mirrors, and promiscuous mode, etc. And we could do that in the distributed virtual switch environment, once again with a performance vision capture appliance on each hypervisor. So we see that those VMs that are vMotion to other hypervisors in order to maintain performance requirements. With that in place, we'll see that traffic. We're sitting at that virtualization space, and we're not worried about that north-south traffic because we're already there. We're at the source closest to the server, which is crucial for packet analysis. So another example, dedicated production virtual distributed switch for server to server, application server to database server, etc. And then another option is ER span, so where we're tunneling the traffic from the PBX appliance or to the PBX appliance from a virtual distributed switch to the capture interface that has an IP on it, so we can actually see that traffic. So that's another option. But we strongly recommend that you use individual PBX capture appliance on each hypervisor to eliminate that traffic traversing that north-south, your top-of-rack switches. Why put that traffic on there if it's as simple as installing a PBX capture appliance on each hypervisor? There's no need to do that. So from an architectural perspective, PBX, we deploy capture appliances, once again, as I've stated, across multiple hypervisors to see that traffic. And then that traffic, as far as hitting that interface or interfaces, is analyzed as soon as it hits it. And then we take that data that we're seeing in every TCP transaction, and we're rolling it up, compressing it, and pushing it up to the data store, which can be another virtual machine or a physical machine, your call. To what your needs are. Right there is where the horsepower is, where the analytics is, and where you're going to actually pay for the cost of PBX, because what we charge you for what we analyze. So the amount of traffic traversing from the capture appliance to the data store is minimal. So if this is a 10 gig interface, this traffic is less than 1%. Actually, it's 0.2% of that traffic traversing from the capture appliance to the data store to give us all the rich information that we saw in all that traffic. Pretty impressive. And then the ability with Flow Broker from the edge or at your remote site to send specific packet capture information, packets, and tunnel it to, a data store with a capture appliance or a capture appliance itself, so we can actually extract that data once again to give you that meaningful east-west traffic, even if it's remote, to your location. And then from PBX Data Store, the ability to extract that data with our rich REST-based APIs, open source to, gain access to that rich data in our database. And we also support VXLAN. So if you're running, VMware's virtual environment, SD environment, we're already ready. We're ready to go to take care of your needs in that space. So I'm just going to pop out of here for now for a second and go over to the environment I have running, just to give you an example. So an example here is I've got a network switch, right? I've got a ESXi server, version 6.5, and actually I have a virtual switch that I have PBX loaded on. So you can see here that I have both the interfaces on, there's two interfaces on PBX, as well the vkernel interface, as well the physical interface, where here's where I gain access, from the management perspective to the network. So here's where actually the IP of the PBX appliance resides, so I can talk to this as a host and gain access to the real network, the physical network, top-of-rack switch, etc. Then from that same PBX appliance, I have another interface that's sitting on a switch port that's actually capturing traffic, between VMs that are on this same VLAN. I can assign those, those NICs to this and actually see that traffic, give me visibility. So no cost to the environment as far as deploying this. And then if I go to another hypervisor where I've got a number of hosts running, and if I look at that same scenario, let me just move this is the PBX console and just the host running ping here as an example. I could show you here that I've got numerous interfaces, and here I've got the PBX appliance, and then here's where I'm actually capturing the traffic. So I'm seeing it on the PBX appliance, a Linux server, a Windows server, and then PBX capture appliance. So I see that traffic. As soon as that traffic hits this interface, I'm analyzing it, rolling it up, and then in turn, I'm sending it to, if I come here to node management, I'm sending it to the data store, which is labeled here as PBX. So PBX 88 is just a capture appliance, and it's as simple as deploying these capture appliances and telling it, securely with a certificate that, hey, you need to talk to this appliance and roll up your data, concurrently, real time. So this is the data store that, collects all the information. And once I have it in the data store, it's as simple as coming into our interface, go to network as an example. Let's say I want to take a look at the last half hour, all transactions, or last hour associated with everything hitting my capture interfaces in EastWest Traffic. You can see here that I'm seeing that at the data store because I have a capture interface on that as well, but I'm also seeing it on that remote hypervisor where I'm actually capturing it off of that PBX appliance there. It all rolls into the data store. So I got complete visibility of the environment. Very powerful and very flexible. So why is PBX different? Unified network performance management, network application performance visibility in one solution. You're not buying modules, you're not buying individual components, it's all inclusive. Quick to set up. As soon as I have that packet capture interface up and running, it's analyzing the data. So it's an OVA file that, as an example here in VMware, I import. I'm up and running, capturing and analyzing the traffic that quickly, within minutes. So it's very quick to get you up and running, root cause, minimal configuration, no agents, etc., and all the way up the OSI model within the packets, all the way up to layer 7. How do we differ from other approaches? Well, where I came from was stream to disk, where we would have these big appliances, big iron appliances, capturing packets and streaming them to a big disk array, terabytes, petabytes. And then we'd have to go in and post-packet analysis when an issue occurred, go back in time and understand what was taking place and analyze the data. That's not true with PBX. Once again, keep repeating this because it's such a huge feature. As soon as that traffic hits the PBX capture appliance, decode, calculate metrics, it's doing the analysis for you. I don't have to break out Wireshark. I don't have to break out Sniffer Pro. I don't have to break out other tools. It's already there, and it puts it in the data store, which is a very rich, fast database for actionable insight into problem analysis. So, we're cutting that that problem out, really quickly as far as that time, so mean time to resolution. And once again, just to repeat, one unified solution, right? We're not selling you transaction modules, network analyzers, TC performance modules, and stream to disk, which is very expensive. Once again, refresh cycles, hardware refresh cycles, etc. We're selling you a solution that's software-based, addresses the public and private cloud requirements and scales to east-west traffic as well, north-south, and brings it all into one, user interface. So universal coverage, once again, virtual, infrastructure as a service, SDN, etc. How do we differ? PBX leverages its pure software sniffer, to deliver agentless performance and virtualized and cloud environments. It's beautiful. And then, hybrid clouds, private clouds, we address it all very easily versus other solutions that need a lot more hardware, a lot more components. Once again, adding the expense and adding to operational costs as far as overall requirements. So that's the end of the slide deck there. And what I wanted to do is just show you some, quick analysis here. So from, a network perspective, have the ability here to, really quickly, let's just say, for instance, bandwidth. I want to see bandwidth for the last, go to my clock here and say I want to see bandwidth utilization across that, east-west traffic environment for the last hour. Just do a search, and there it is. And I don't have much traffic in this environment. I apologize for that. But it shows really quickly how fast we can get to the data, because we're searching a database, folks, versus doing post-packet analysis. And then the beauty of it is I can actually get a trace file if need be. So I can come here and configure thresholds for triggers to actually create, a trace file, a network trace file once we exceed thresholds. So we're actually giving you the best of both worlds, key metrics, in order to actionably troubleshoot the problem right here in this GUI from the database, as well a trace file that you could hand to your vendor and say, hey, it was a load balancer problem, or it was, this switch problem, and hand it to the vendor based on thresholds being exceeded. So we can create threshold-based PCAP file generation. So very powerful. And then we can do specifics as far as searches very easily, like IP. So if I come here and say, for the last, 12 hours, find source or destination, find me an IP address. Let's find that end user's IP address who just opened a trouble ticket. And I can see all transactions to and from that end user's machine and actually do a deep dive on that trace just by a single key click and see all the data and see where it came from, where it traversed. Look at the application layer. So, HTTP here, where I'm actually seeing, that this transaction, and I'm seeing key metrics that we're generating, round trip, and then data transmission across the wire, so how fast it takes to put that data on the wire, and then SYN-ACK connections. So, once again, it's a database, so it's very fast, very efficient, gets you to root cause that much quicker, and then the ability to create instantaneous reports, just by creating a PDF to send to, the remote team that's supporting that client or that server, and automate this. So I can have reports that are automated, that are emailed, that's, send based on a trigger when something's exceeded. So Yasmin, I'm running low on time here. I think I'll stop here. I'll let you engage and ask questions.
Thanks, Al. That was great. Does anybody have any questions? Let me go check my little box here. Okay. Oh, I have a question. It says, is your PBX virtual capture appliance capable of capturing traffic at 1 gigabyte per second and 10 gigabyte per second traffic rates?
Oh, great question. Thank you, Yasmin. Absolutely. So once again, let me just bring up the slide here real quickly in the topology. So that environment where we're actually seeing the traffic and having it hit the interface, these interfaces can be 1 gig or 10 gig as well. This could be a physical appliance. We can put this, we could sell you a physical appliance where actually it's a 1 gig or 10 gig interfaces, once again up to 8, so we can capture, at 1 gig or 10 gig line rates. Great question. Thanks, Yasmin. Any other questions?
Yep, there's another one over here. 1 second. How much additional network traffic is generated when the PBX virtual capture appliance sending its data to the PBX data store appliance?
Oh, great question. And I kind of talked to it, but I'll just reiterate because it's very important. It's very lightweight. As soon as we hit this data, the packets are hitting this interface, we're analyzing it, and we're compressing that data and creating key metrics and pushing that data up to the data store. So that's less than 1%. Actually, it's 0.2% of traffic that we send at max between the PBX capture appliance and the data store. Very lightweight, so this scales out. So I could have numerous packet capture virtual appliances or physical appliances seeing and capturing traffic, analyzing it, and feeding it to a data store. That's how this architecture scales and its flexibility. Thanks. Great question.
We have another one, actually, and it's how many CPUs are required for 10 gigabytes per second analysis?
So it all depends on how many interfaces you want. And I'll just bring up, here, bear with me a second, I'll pull up a slide that actually talks to that. Oh, shoot, I'm not finding it. You know what we'll do? Get that person's email and I'll send it to them. But I believe it to be only 4 virtual CPUs.
Perfect. Thank you.
All right, I apologize for that. Didn't have the slide ready for that. Couldn't find it. Sorry.
And then lastly, I have, does Exedian offer a similar solution for capturing EastWest traffic in the public cloud, like AWS and Azure?
Absolutely. So we're going to be releasing them very shortly our capture solution for those environments. So once again, scaling to the public cloud in a big way. That'll be out shortly within the next couple months. It's already in beta test.
Great. And another one, how latency metric is measured on HTTP layer?
Oh, okay. So every TCP session that we see, we calculate the round trip, which is your SYN-ACK. We also calculate the application layer response, data transfer. So we're seeing, all the back and forth within each TCP session, capturing unique metrics, which we refer to as the overall transaction response time, EURT. And then we capture data transmission, how long it takes that data to be, once you make your request, application request, and to get all the responses back, how long it takes to transmit that across the network. We're capturing all those details in every single TCP thread. And, providing these rich metrics which again, EURT is crucial. So from a single screen, I could tell that, hey, out of 3,090 transactions, I'm averaging an end user response time of 300 milliseconds. Round trip client and server, that being the network, right? Latency, 60 milliseconds to 49. Server response time, that being, I'm sitting, I made a key click, I, presented a whole web page request, and I'm sitting there waiting for the data to come back down to me, the client. It's taking 141 milliseconds behind that web tier to put that data together. Then when it gets that data, to put it on the wire, data transmission client, data transmission server, it's fast. So I can tell right here, network and data transmission are relatively low. The vast majority of that 300 milliseconds is behind the web tier. So, it's most likely that east-west traffic again, folks, that database, that middle tier, that's slowing things up where I'd have to go see and, why we've exceeded the threshold, why our normal, end user response times are maybe 200 milliseconds and now they're 300, so we know right away it's not the network, it's actually behind, the north-south traffic. It's the east-west traffic I need to look at, server to server, web tier to application tier to database tier. And we're generating all these key metrics from it in each TCP session. We're not sampling. I got to stress that again. So this is total packet visibility, all rolled up, done for you versus, I'm having to break out a trace file, Wireshark, and take a look at it. Once again, these thresholds, if they're exceeded, we can trigger a trace file to be captured, so you have the best of both worlds. I'm still a packet guy. I still use Wireshark. I still go to SharkFest every year, the Wireshark end users meeting every year. I'll always do that, but I don't have time for it every day. I don't have time in my day-to-day practice to look at every trace file. I need to get actionable information very quickly to solve the problem. I kind of elaborated on this because this is a key point of what we offer, especially in that east-west traffic environment, to get you to root cause. Any other questions, Yasmin?
I think that we really do, actually. We have another one. Can TWAMP be used for this latency measurement?
It can. So that would be, related to, let me just roll up that one slide again. Sorry, having a little PowerPoint miscues here. I apologize for the slowness in snapping these up. So that's where VCX comes into play. So in addition to seeing real-time, packet analysis with PBX, we can actually leverage VCX to utilize TWAMP, et cetera, with Flow Broker to do synthetic transactions across the network to gauge that. And then that all rolls into Data Hub IQ to give you that performance dashboard that you need to see, the correlation between PBX, what we're seeing in real-time packets, and what you're seeing at the infrastructure synthetic testing layer. Gives you the best of both worlds. So I'm seeing, if there's microsecond burst, traffic bursts that are slowing things up, I'll see that with VCX, and I'll see the cause and effect of those microbursts with PBX as the actual applications traverse that network. Great question.
Okay, well, it appears that we're really out of time, so I just wanted to thank everybody for attending. If you have any further questions, please feel free to email Al. I will be posting the recording and emailing it to you as soon as the webinar is over. So thank you for attending, and we hope you'll be able to join us for our next one. Have a good day, everybody.